Hello everyone. Today I am before you to take the next and the last topic of physics, that is sources of energy. You all know in order to work we need some energy, and we know that capacity to do work is called energy. But if we just think, from where are we getting this energy? Yes, by the food that we eat, we get energy to do work. Now, food becomes a source of energy for us. We eat vegetables. There are different kinds of sources. Like we have fruits, we have vegetables, right? And people, those who are non-veg, they eat non-veg, right? Water is also kind of energy. When we are thirsty, we feel uneasy. So at the time when we drink water, we feel good. So water also becomes a source of energy. But when it comes to physics, the topic that you are going to study, that is sources of energy, is related to the availability of sources in the environment. So those are categorized into different. One is renewable source of energy and one is non-renewable source of energy. This detail we will be studying today. So first, what we will be studying here is definition of sources of energy, then categories or the parts of source of energy, or in which they are divided, source of energy, how they are divided, then what is a good source of energy, how to select which is good source of energy. Okay, that also we will study in this chapter. Then we'll study about what is a fuel. Then characteristics of a good and an ideal fuel also we will be studying. What is definition of source of energy? Source of energy that can provide adequate amount of energy in a convenient form over a long period of time. You could see the pictures here. You have sun, you have biomass, the dead and decaying plants and animals, okay, which is also called as fossil fuel. Then we have hydropower, then geothermal, wind energy, oil, coal, natural gas, nuclear energy also, nuclear fuel you can say. Okay, so these all are sources of energy. So we use oil, that is in the form of petrol, diesel, in order to run vehicles. Even kerosene also used to use, right, to lit a lamp and all. Then we have coal in the engines they used to use, and in thermal power plants also they use this coal, yes, to generate electricity. Natural gas, one which we have the methane, that is LPG gas, right? So LPG gas which we use to cook food and all, right? Then sun is the ultimate source of energy. Then with the help of wind energy we are going to generate electricity, then geothermal energy, hydropower. So there are plenty of source of energy. Okay, out of these, which is good and which is bad, that we will be studying. So the definition of source of energy is the sources of energy which can provide adequate amount of energy in a convenient form over a long period of time. So coal we got in a solid form, that is a convenient form, yes, and we get a lot of energy also from that. Oil and then gas. So now let us see what are the categories of, or how the source of energy are divided. So they are divided into two parts: renewable source of energy and non-renewable source of energy. In renewable source of energy we have wind energy, solar energy, tidal energy, hydro energy, right? Sea wave energy, ocean thermal energy, geothermal energy, biomass energy. So what are these renewable source of energy? The energy, the source of energy that can be used again and again, or that can be replenished after its usage. We call it as renewable sources of energy. And examples of renewable source of energy are wind, solar energy, tidal energy, ocean. These all 8 are the examples for renewable source of energy. Next we have non-renewable source of energy, right? So under non-renewable source of energy we have fossil fuels, coal, petrol, diesel, kerosene, natural gas, nuclear fuels, right? So these are non-renewable source of energy. So why they are categorized into non-renewable source of energy? What do you mean by non-renewable source of energy? The non-renewable source of energy is once if it is used, right, it gets exhausted, right? For example, coal. If you take coal and when you heat, okay, when you give it a fire, when you burn the coal, the residue will be into ashes. That taking that residue, we are not going to generate coal. Will not get coal. For example, you all will ride bike or you have a car. So when the petrol tank or the diesel tank is empty, you fill petrol, then you drive, and then after a few kilometers, right? So the petrol will be over. It is not going to regenerate or it is not going to replenish. Okay. Once again, you have to fill petrol in order to run the vehicle. So after certain usage, if the sources of energy is exhausted, then we call it as non-renewable sources of energy that cannot be replenished. So we call it as non-renewable sources of energy. Now to understand which is a good source of energy, okay, how to understand the good source of energy? We have a few points here. One is which is reasonable and easily available. That means, in other words, which is cheap, right? Which can be affordable, which we get in a reasonable rate, okay? And easily available, that should be easily available. Then we call it as a good source of energy. For example, wood is easily available for us, so it can be considered as a good source of energy, right? But every source of energy has its own advantages and disadvantages when we compare with another sources of energy. I hope you understood this one. So what is a good source of energy is which will be following, which will follow or which will have all these properties which we are going to study now. So one, it should be reasonable and easily available. The next one is which would do large amount of work per unit mass of volume, per unit mass or volume of fuel supplied. We talk about mileage, right? So we say that per liter 50 kilometers can be run, right? 50 kilometers per liter. For 1 liter of petrol, if we are filling into the tank, that can run up to 50 kilometers, right? So then we consider it as a good source of energy. But as and when you are going to use, what is going to happen? There are chances that mileage may decrease if you are not going to go for the proper servicing and all. Then what is going to happen? How do we say that it is not a good source of energy? Or it depends upon how much work is being done in that unit mass of fuel or unit volume of fuel. As I said, if the ideal average is 50 kilometer per liter in the initial time or 60 kilometer per liter, as after usage, if at all, it is going to give us the mileage of 30, 35 or 40 per liter, then we say that fuel is not a good source of energy, which means that one which is going to give more amount of work per unit volume or per unit mass of a fuel that is being supplied. Next is which is easy to transport and store. That means the sources of energy, it might be any, it might be petrol, diesel, LPG, anything we can take that should be easily transportable, that we can transport them easily from one place to another place. And the next one is that we should store it easily. Okay, that should be stored easily. Then we have next point, that is which is safe to use, right? Which is safe to use as to handle. I hope you have understood this one. Which is safe to handle and use. Next, which does not cause pollution. Even but considering the environmental causes also, we need to check whether the source of energy that we are using, is that going to harm the environment. If it is going to harm the environment, then that source of energy is not considered as a good source of energy. Okay, so please, once again, to understand, if at all they ask, if the question is asked, what is a good source of energy, or how are you going to identify a good source of energy, or what are the characteristics of a good source of energy, then your answer should be that the source of energy should be reasonable and easily available, and it should do large amount of work per unit time, per unit mass or volume of a fuel that is being supplied, and that which is easy to transport and store, and also safe to use and safe to handle, and also that does not cause any pollution. Okay. Next, what is a fuel? We all know, we all use fuel. Okay, for at home to cook we use LPG gas, that is the fuel. Okay, and then for running our vehicles we use petrol, diesel, that is also a fuel, right? The food that we eat is also a fuel. Why? Because the food that we are going to eat, that will be broken into simpler particles, and then that provides us energy. So here also, so in physics, in this source of energy, what is a fuel? That is, the materials that are burnt to produce heat energy are known as fuels. The coal that we take, okay, if at all that coal is being burnt, what it is going to give heat and light energy. So when the materials that are being burnt to produce heat energy, we call it as fuels. So as and when the petrol is filled into the tank, okay, in the vehicle, so what is going to happen? As and when we are running, the fuel it is getting burnt, and then it is going to give energy to the vehicle to run. The food that we are eating, that is being broken into simpler, the complex food is broken into simpler particles. Okay, and soon after eating, you could see that after having food, our body will be heated, right? It starts sweating. That means it is giving out heat energy. Yes or no? So similarly in the vehicles also it acts, or the industries and all, even in thermal power station, the coal is being burnt, okay, and that coal, when it is burnt, it will heat the water, and then that heat will be, the water gets heated, and then steam is being formed, and that steam is passed over the turbine. Then the turbine rotates with the help of this steam, and then that turbine will in turn be connected to the generator. The generator will be rotated and electricity will be produced. Okay, so what is fuel? The answer should be the materials that are burned to produce heat energy are known as fuels. Example, these are the examples: coal, oil, that is petrol, diesel, okay, kerosene and all. Wood is also a fuel, okay, because when we burn wood, it gives heat energy, right? And then we have natural gas, that is LPG, yes, or even you have CNG also, compressed natural gas, okay. Then what are the characteristics of a good fuel or an ideal fuel? How do you say? So it should have a high calorific value. So what do you understand by calorific value? So one which is going to burn completely and give heat energy, right? So calorific value is like once that is burnt completely. So suppose if you are taking a coal, okay, so if it is burnt completely, when it burns completely, then it is going to give heat energy, right? So that is called as calorific value. Okay, so it should have high calorific value. That means it should give more energy, it should give more heat energy. Okay, next is it should burn without releasing smoke or harmful gases. It should burn without releasing smoke or harmful gases. So whenever a fuel is burned, it should not leave any smoke or any harmful gases, due to which the environment may get polluted. Next, it should have moderate ignition temperature. So it should have moderate ignition temperature. What is ignition temperature? So whenever you supply heat to a fuel, okay, first it gets heated up and then it catches fire. So that minimum temperature, that is the minimum temperature required for a fuel to burn, is called as ignition temperature. That minimum temperature in order to catch fire or in order to get heated and then catch fire should be moderate. It should not be too less or it should not be too high. Okay, so if it is too less, then hazardous may take place. If the temperature is too high, then it takes more time to get heated. So any fuel which is called as good fuel or as an ideal fuel, it should have a moderate ignition temperature. It should be affordable and easily available. That means it should be cheap. Okay, it should not be too costly or too cheap also. It should be affordable, wherein a common people can also buy that one. It should not be too costly and it should be easily available. Okay, if not, there will be an energy crisis. If it is not easily available, then we'll not be able to carry out the work. It should be easy to handle, safe to transport and convenient to store. Almost all the points we will be getting from the good source of energy. The points that are for a good source of energy can also be added in for the good fuel. Okay, few extra points, that is calorific value, ignition temperature. So these are, it should burn smoothly. So few points that has to be added for a characteristics or qualities of a good fuel. Okay, it should not leave much ash or residue after when it is burned. Okay, after burning, for example, as I said, coal. So when the coal is burnt or wood is burnt, so it is going to leave ash. So it says that it should not leave much ash or residue once it is burnt. Okay, and on the other hand, it should burn smoothly. Okay, it should burn smoothly. Now, in today's class, we are able to define source of energy and its types, right? And then qualities of a good source of energy and an ideal fuel. We have learned about what is calorific value, then ignition temperature, and also now we are able to differentiate between good and bad source of energy. So these are the assignment questions. You can note down this, that is, give any three examples of a renewable and non-renewable source of energy. The calorific value of a hydrogen is 150 kilojoules per gram. What does that mean? Which means that per gram, how much energy it is giving? It is giving 150 kilojoules of energy. So the calorific value of hydrogen is 150 kilojoules per gram, means per gram it is going to give 150 kilojoules of energy. It is given by the hydrogen. Okay, so whichever the fuel, if the fuel is going to give more energy per gram, then that will be called as high calorific value. So whichever has high calorific value, then that will be considered as a good fuel. Okay, one of the following is not a quality of a good fuel. So smooth burning, no emission of smoke, low ignition temperature, low calorific value. So the answer is low calorific value. Okay, so ideal fuel or a good fuel should have high calorific value. Okay, now next, the calorific value and ignition temperature of a fuel A are 55 kilojoules per gram and 80 degrees Celsius respectively. These values for fuel B are 80 kilojoules per gram and 10 degrees Celsius respectively. On burning, the fuel A produces carbon dioxide and water, while other fuel B produces carbon dioxide and sulfur dioxide. Which fuel would you suggest is better and why? Now, as we have already studied, the ignition temperature should be moderate and the calorific value should be high in order to consider it as a good fuel. And on the other hand, it should not leave any harmful gases also. When we are considering the fuel, an ideal fuel or a good fuel, it should not leave any harmful gases after burning. Okay, on burning, it should not leave any harmful gases is one point. Second point, it should have a moderate ignition temperature. It should not be too high or too low. Then the third point is an ideal or a good fuel should have high calorific value. Now if we compare here, A and it has got the calorific value 55 kilojoules per gram. That means per gram it is going to give 55 kilojoules of energy. Whereas fuel B is giving 80 kilojoules per gram. Here, if we consider only on calorific value, then fuel B is better. Okay. Then on ignition temperature, it is taking 10 degrees Celsius, right? Fuel B at 10 degrees Celsius it is getting burnt, whereas fuel A at 80 degrees Celsius it is going to get ignited. Okay, so ignition temperature is 80 degrees Celsius and for fuel B it is 10 degrees Celsius. On burning fuel A, it produces carbon dioxide and water. Okay, and whereas fuel B produces carbon monoxide and sulfur dioxide. Okay, so which is the harmful gases, okay, which are producing harmful gases? So if you go, then fuel A is better fuel than, because the temperature is, though it has got high calorific value, but the ignition temperature is not moderate, it is too less, right? At very least temperature it is getting ignited, and also it is leaving the harmful gases. It is leaving harmful gases, that is carbon monoxide and sulfur dioxide are harmful. They may cause acid rain also, right? So they are harmful gases, so which will not consider. So whereas fuel A would be suggested as a better fuel than compared to fuel B. Okay, so I hope that you have understood this one. And one more thing that I want to say you is that, so this class, this source of energy is a deleted portion, okay, just to cover up the syllabus and to make you understand, so that you will have a better idea like what has, suppose in higher classes if you come across these topics, you should be knowing the basics. That is the reason this topic is being taken. So try to understand, go through this video. Okay, next in the next class we will come up with the working of the thermal power stations, hydro power stations, nuclear energy, etc. Okay, thank you so much. You all have a great day.